Hi everyone and welcome. In today's short video, we're going to take a look at this problem that seems pretty simple but has a very elegant solution, or at least in my opinion it does. In this problem, we are given a triangle along with some pieces of information about that triangle, and the goal is to find the missing angle. So let's read through the problem statement. The problem statement says that we're given a triangle x, y, z. We're also given that M happens to be the midpoint of the segment yz. What is the midpoint? Well, the midpoint just cuts a line segment in half. That is that ym should be the same length as mz, right? The midpoint cuts it in half. We're also given two angles. If you look at angle xmz, which is this angle, it's given to be 30 degrees. We're also given angle xyz, which is precisely this angle y, it's given to be 15 degrees. And we need to find angle xzy, which is this angle. I labeled it in orange theta. That's the goal. Now, when you look at this diagram, there's a few obvious things we can begin by doing. I mean, we can find probably this angle is just going to be 180 minus 30 degrees. We can probably also find this angle once we find this one, because all the angles in a triangle sum to 180. And so yes, let's begin by determining those two angles. All right, so let's call these two angles alpha and beta. Then alpha, as we just discussed, is going to be 180 degrees minus 30 degrees. And so that means this angle is 150 degrees. Great. And now to find angle beta, since all the angles in a triangle sum to 180 degrees, we can just do 180 minus 15 minus 150, and that will give us 15 degrees. And so angle beta is also 15 degrees. And now the problem gets a little bit more tricky. You have to make a few cool observations in order to continue. And so now check this out. If you take a look at triangle XYM here, what we have is that two of the angles are 15 degrees. What does that mean? That means that this triangle is isosceles. That is that two of its side lengths must be exactly the same. That is, side length YM should be the same as XM. Let's call this common length L. Okay. Now we also know that M is the midpoint of YZ. That is, it splits this line segment into two equal halves. So if this one is L, well then this one should also be L. Well, now if you take a look at the triangle XMZ, then this must also be isosceles, because this is L and this is L. And so this is very, very nice, because that means that angle MXZ, this should also be theta. And so this is the trick to solving this problem. And so finally, to solve this problem, since triangle XMZ is isosceles, right, these two angles are equal. So what we can say is that the sum of all of these three angles must be 180 degrees. And so this is a linear equation. In a single variable, we can solve this no problem. We subtract 30 on both sides, we get 150 is equal to theta, divide by 2 on both sides, theta is equal to 75 degrees. And so therefore, the angle Z that we're looking for this larger triangle is also going to be 75 degrees. And so now, taking a step back, I really enjoyed this problem because you really have to be observant and make this observation that the triangle that you're working with here is isosceles. And so that means that these two side lengths are equal. And then you use the given midpoint to determine that this must also be L. And then you make the observation, wait a second, the other triangle is also isosceles, which means that this angle must be equal to this angle. And then you're able to get to the final answer, which I found to be pretty fun and elegant. Thanks for watching. If you enjoyed this video or found it helpful, I would really appreciate it if you could like the video and subscribe for more content. And if you have any questions or thoughts, feel free to leave a comment down below. I would love to hear from you.